Okay, so in this video, I'm going to go through the restriction enzyme method. So for this first problem here, they ask you to give the lengths of each of the fragments that are obtained. So when we are looking for the eco-RI lengths, what we are going to do is we are going to pretend that the BAM are not there. So we're just going to ignore them. So we see that we have one cut on the eco-RI right here. So our fragment is going to be this whole piece. So our fragment is 4 plus 2 plus 6 plus 8, which gives us 20. So we have a fragment of 20 for eco-RI. Then we are going to do the opposite. When we are looking for BAM, we are going to pretend that eco-RI is not there. So we can see that we have one fragment here, one fragment here, and one fragment all around here. Remember, if we have a circular piece of DNA, and have 3 cuts, we need 3 fragments. So we have a 2, a 6, and then we have to do 4 plus 8 to get our last fragment, which is going to be 12. Then finally, we are looking at a double digest. So double digest is when we put both restriction enzymes in the tube at once. So we're going to get all of these cuts. So we are going to have a 4, a 2, a 6, and an 8. So those are our fragments for our double digest. If you look, we can tell we want to make sure that our double digest doesn't add up to more than what our actual or our total length is. And it tells us our total length up here is 20 kb. We can also get that from the eco-RI because the eco-RI only cuts once. So that is how you figure out the size of the fragment when you are given a restriction method. Next, they give you the fragment lengths, and they want you to build the restriction map. So first thing to notice is that our HPAL only has 1 cut, so that means our total length is 26, right? So, what I tend to do is just kind of break this up into a clock. So I start with putting my 12, my 6, my 3, and my 9. Then we have 1, 2, 4, 5, 7, 8, 10, 11. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. So then what I would do is I take 26 divided by 12 to give us just kind of a rough estimate of what each one of those segments are. So it gives us about 2. So each one of those is about 2-ish, 2.16. So next, we know that HPAL has only 1 cut. And we know that we are going to end up getting 5 fragments at the end, but we have 4 fragments from HIND 3. So what I would start with is doing the HIND 3 cuts and then placing our HPAL fragment or our HPAL cut where we need it in order to make the extra fragments that we have. Okay. So our hand 3 has one that is 13. So I typically start at 12 o'clock. So here's going to be our first cut, H. I'm just going to label it H3. So we need 13. So we go 2, 4, 6, 8, 10, 12, and about 13 is going to be our second H3 cut. So we have that one done. Next, we need about 6. So we have 1, 2, 3, 4, 5, 6. So this is going to be our other H3 cut, right? Then we need one that's about, well, let's do the 3 first. So we have 1, 2, 3. Oh, this is one. How did I do this? You can see how this is kind of like a logic puzzle of sorts, right? So I thought this, you think this is going to work? I thought this was going to work. This must not have been how I did it. Let me erase. Where's my eraser? Make it small so I don't erase everything. Okay. We're going to start over. So we have 12, 6, 3, 9. Let's see. Okay. So we are going to go here actually and break this into more pieces, 1 to 12. Okay. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pieces. So 26 divided by 16 is about 1.6. So we can still, so 26 divided by 16, 1.6. Let's see if we can round that up to 2 again. Okay, so we start here. We want 13. 2, 4, 6, 8, 10, 12, 13. So H3, H3. Let's do our 6 again. So we have 1, 2, 3, 4, 5, 6. And 4. 1, 2, 3, 4. That leaves us with way too much. Okay. So this is kind of a guessing check to figure out how it is best to estimate and to break up this circle. Yeah, let's say it's 1.5. So H3. Okay. So it's going to be something like that. So these numbers don't work out completely, but that's okay. So we end up with our last one being just under 3. But essentially we have our 13, our 6, our 4, and our 3. Okay. Now that we got that figured out, we are going to look back up at these numbers, and we are going to see which numbers there pair or match up. So we have a 4 and a 4, a 3 and a 3, 1, 6, and 1, 6. So we know that we will not touch our 3. We will not mess with our 3 piece, our 4 piece, and our 6 piece because we have that in our final restriction map with our double digest. So we know that we need to break our 13 up into 2 pieces, one that equals 7 and one that equals 6. And that is going to be about, so here-ish. So this isn't 13 anymore. This is our H cut. And this becomes 7 and this becomes 6. So that is how you work this out. Like you saw, it can be a bit of a logic puzzle working through it all. So just take your time. Definitely recommend using pencil when doing this or something that is erasable. Next, we are going to draw our gels or our bands on our gel based on our restriction map. So let me see if I can zoom in slightly more. Okay, so again, we're looking at BAM and EGO-RI. So first, and PSTI. So again, first we have EGO-RI and PSTI. So what we're going to do is we are going to get rid of BAM. That does not cut at all. So for EGO-RI, oh no. Bear with me. So when we are looking at our EGO-RI and PSTI, we are going to get rid of BAM. That doesn't cut. So we have an EGO, we have one piece that is here and one fragment that is here. So our long fragment is going to be 1.94 plus 0.2, which gives us 2.14. So that is going to be our first band. And then our second band, we don't have to add anything. It is just 0.46. So then this is just like drawing a gel like we normally would. We go based off of our ladder, and mine might be slightly off because my board isn't quite calibrated. The 2.14 is going to be just slightly above our 2.0, and 0.46 is going to be just slightly below our 0.5. So then we have our EGO-RI and our PSTI. Next, we are looking at EGO-RI and BAM-HI. So we get rid of our PSTI. So we have a fragment from here and there. So our long fragment is going to be 1.94 plus 0.46, which gives us 2.14. 0.40. So that is our first one. And then our next one is just 0.2. So again, we're going to draw these on our gel. 2.40 is going to be above our 2.2. So I'm going to say it's about right there. 2.0. Remember this one, this red one is 0.46. So 2.0 is going to be below 0.46. Then lastly, we are looking at a triple digest. So we have all of our enzymes in there. So we are not going to erase any of the cuts. We have a 1.94 fragment, a 0.2 fragment, and a 0.46 fragment. So 1.94 is going to be about here. 0.46 is going to line up with our red one, and 0.2 is going to line up with our green one. So that is how you would do that or draw gel based on our what do you call them? Our restriction maps. The last page gives you a gel and has you make a restriction map. So we can estimate that, first looking at this, we can see that EcoRI has only one cut. So that is going to be our full length of our plasmid. So that means that our plasmid is going to be about 20 kV long. So again, we are going to start with drawing our BAM, and then we're going to come in with our EcoRI. So this one, how did I break this one up? We did 12, 6, 3, 9. Okay, I did this. Okay. This is 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm gonna do this. Oh no, I think I broke it up into 20s. Okay, actually 20. Okay, so one, 2, 3, 4, 5, 6, 7. Yeah, I broke it up into 20 pieces. That means we are gonna need this to be a little bit thinner. Okay. So to break it into 20, we need 5 pieces. So 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I don't know, I'm messing myself. Okay, so I broke it into 20, so it's super easy for us to work with now. So we have one BAM HI piece that is 11. So we're going to start here with our BAM. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is our second BAM. Then we have one that is about 6, right? We're going to go 1, 2, 3, 4, 5, 6. And that is our third BAM. And then we have one that is 3 there. So again, we are going to look at the bands and see which ones match up. So we have a 6 and a 6. So we are not going to touch our 6 piece. And we have 1, 3. So we are not going to touch our 3 piece. So that means we need to break our 11 piece into a 3 and an 8 piece, right? So we have our second 3 and our 8 right there. So I just counted backwards. So 1, 2, 3. So this is our equal RI piece. So this becomes 8, and that is 3. So that is how you go through all of this, how I work through all of this. As you can see, it can be a bit of a process, even for someone who has done it for a while. So it is a bit of trial and error to see how everything can fit on the plasmid, but as long, it doesn't have to be perfectly accurate. It has to be close, but like we saw in the first plasmid that we mapped out, there was a bit of rounding that happened, but it's still represented in the plasmid accurately. I will be posting, or I posted my answer key with this also. You can see, you can go back and look at the answers. But if you have any questions, please do not hesitate to reach out to me and let me know.